All right. So, 7.2. Let's get this started. What is this shape right here, you might be asking? Let's put a smiley face in here. Actually, today's not a smiley day. This is the day after the Lions lost. It is a frowny day. Oh my god. What is this shape right here? Well, it is a parallelogram. Funny enough, today is properties of a parallelogram. Ooh. A parallelogram. That is also a quadrilateral with pairs of opposite side parallels. What does that mean? Well, good question. It means that we have all four sides of this quadrilateral having parallel properties. Like we have these two sides in green being parallel with each other, and I'll use a different color for the other two sides. These two sides are also parallel with each other. The different colors should help with visualizing what sides are parallel to what. Also, the single arrow to double arrow should help as well. But these two sides are going to be parallel with each other, and these two sides are going to be parallel with each other. That's the basis, bare bones definition of a parallelogram, but there are different properties of a parallelogram that we can figure out. Now, you should have figured this out when we did the basketball court stuff, but we're going to formalize it in our notes right now with the next few theorems that we are going over. The first one is going to be theorem 7.3, the parallel opposite sides theorem. And that states that if a quadrilateral is a parallelogram, then its opposites or its opposite sides are congruent. So they are the same length. I cannot spell congruent to save my life right now. There we go. So that means if PQRS is a parallelogram, then the segment PQ is going to be congruent to RS, and I'll get a different color. And segment QR is going to be congruent to segment PS. So the green lines are going to be parallel with each other, and the blue lines will be parallel with each other. Well, yeah, they're parallel. The congruent, I meant congruent. I meant congruent. Congruent, same length. So they share same length. Cool. That's theorem 7.3. 7.4. It's the parallel opposite angles theorem. That one states that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So if PQRS is a parallelogram, then angle P will be congruent to angle R, and angle Q will be congruent to angle S. So these two angles are going to be the same angle measure, and these two angles are going to be the same angle measure. Again, not too bad. We kind of dealt with similar properties beforehand in Unit 3, and we'll touch back on that in a minute or two, but knowing these two properties, these two theorems, can help us solve problems like this, where we have to find the value of x and y, and we're kind of just given random values everywhere on the board. But fear not, we can find x and y very easily. We'll do x first. By using 7.4, we know that angle R and angle P are going to be congruent with each other because they're opposite angles. So that means I can set 2x is equal to 54. And then I can divide by 2 to get x all by itself, and I'd end up with x equals 27. Cool. And likewise, with using theorem 7.3, I know that these two angles right here are congruent with each other. These two angles. These two sides, SR and PQ, they're congruent to each other. So that means I can set 20 equal to 3y minus 1. And I can work on getting y all by itself. So I'm going to move the 1 to the other side to get 21 is equal to 3y. Now I can get y all by itself by dividing by 3 on both sides. And I'd end up with y equals 7. Not too shabby, isn't it? All right. Speaking of 7.3, not 7.3, Unit 3, there's something we can recall from 7.3. Now, I don't know if you guys have remembered this little moment that we had, but there are some problems that we had with transversals and parallel lines, and we might have come across a picture like this. And we had to find like values all over the place on this grid. I definitely have given you a problem like this beforehand. This was kind of a foreshadowing onto this part where we can find the, I don't know, relationship between the angles a lot easier. Knowing the information about parallelograms now and stuff from Unit 3 kind of formulated this new theorem for us in 7.2. It's theorem 7.5, the parallel consecutive angles theorem, where that if a quadrilateral is a parallelogram, then I'll flip the page. Its consecutive angles are supplementary. So like these two angles up here, x plus y is equal to 180. These angles right here, and here, and here, all equal 180. Same process down here. So that means if quadrilateral PQRS, or if PQRS is a parallelogram, then x plus y is equal to 180. This is a consecutive angles, not a linear pair. Consecutive angles, they're next to each other, they can add up to equal 180 degrees. Now this was probably the hardest one to do in the gym, because it's not really, it was hard to do with a rectangle, and rectangles have special properties that deal with diagonals that work off of this, but it's a little harder to see. Either way, Theorem 7.6 deals with diagonals of a parallelogram, given that it's called the Parallelogram Diagonals Theorem. And it states that if a quadrilateral is a parallelogram, then its diagonals bisect each other. Remember that bisecting means splitting a segment or angle into two equal halves. So that means in our quadrilateral PQRS, if PQRS is a parallelogram, then PM is congruent to MR, and QM is congruent to MS. Put all those line segments on there. All right. Cool. Those are the 4 theorems that we're working with, pretty much. And now we can... Cool. Those are the 4 theorems that we're working with, and now we can kind of start doing problems that work with them. So looking at example 2, in parallelogram PQRS, angle P is 4 times bigger than angle M. Find the measure of angle P. So you should definitely draw out your figures. And remember, when drawing out your figures and when you label them, you gotta go by the order of the letters. So if I start with angle P up here, or if I start with P up here, I gotta go Q. And then right next to Q is R. So I have to make sure that R is right next to Q. So I have to put R down here and then S. You cannot have R and S right there. Like R, if R was here, that'd be no good. If S was here, no good. It has to be all lined up just like how the letters are. And now we can start like plugging in our stuff and figuring out what we want to do. So angle P is 4 times bigger than Q. So I'm going to say that Q is going to just be X. And since P is 4 times bigger than Q, so that means it would be 4X. And now I can set everything up to solve for angle P. Solve for the measure. What I mean by this is that remember that these 2 angles are going to be consecutive angles by theorem 7.5. So that means I can do 4x plus x is equal to 180. And then I can combine my x's to get 5x is equal to 180. Divide that by 5. And that will leave me with an x equal to 36. So that means right here, that angle Q is 36. And then I can take this x and plug it into angle P. So that means I'll have 4 times 36, which is equal to 144. So the measurement of angle P is equal to 144. Gotta make it look a little symmetrical, so I gotta put it inside. Make it look nice. Last example, we're going to find the values of x and y. This is eerily similar to theorem 7.6 because it seems like we're dealing with diagonals. So that means by theorem 7.6, these diagonals are going to be congruent with each other. So I can set 5y minus 16 equal to 3y. And 2x plus 10 equal to 4x minus 2. And I can solve for both x and y. X and y. I was going to do x and y. No. X is right here, y is right here. Either way. I'm going to subtract my 5y over. So I'd end up with negative 16 is equal to negative 2y. Get that 2y over to the other side by dividing it on both sides to get y by itself. And I'd end up with an 8 is equal to my y. And then I'm going to move my 2x over for, I don't know, this equation. So I end up with 10 is equal to 2x minus 2. Move this 2 over to get x fully by itself. So I end up with 12 is equal to 2x. Divide by 2 to get x finally by itself. And I'd end up with an x equals 6. Not too bad. And that's it for 7.2.